Hopefully the sound's working. Okay, we're going to talk about derivatives of exponential and logarithmic functions. And this is the last section of chapter 4, and then we'll have a tape, so we'll see how it works as we go through here. We're going to talk about derivative of e to the x, derivative of a to the x, derivative of ln of x, and derivative of log base a of x, power rule for the arbitrary real powers, and why the relationship between exponential and logarithmic function provides a powerful differential tool called logarithmic differentiation. So let's get started. The derivative of e is the easiest one. Derivative of u is a differentiable function of x. Then derivative of e to the u is e to the u du dx. So derivative of e is e. That doesn't change any. So as we look through here, let's look at a problem here. Derivative of y, if y is equal to e to the x to the third. E to the x to the third, where u is x to the third. So we're going to leave u be x to the third. The derivative of e to the u is e to the u times the derivative of the exponent. Derivative of x cubed is 3x squared. Now we're going to put x cubed into the equation, so we get e to the x cubed times 3x squared. And so the derivative of this function is this. So derivative inside and outside. If u is a differentiable function of x and a is greater than 0 and a does not equal 1, the derivative of a to the u, now notice my exponent's up here, is equal to a to the u natural log of a derivative of u over x. So we add some extra components to get longer as they go here. So for example, we got another one here first. The derivative of a natural log of u is equal to 1 over u du dx. So we got this one, a to the u ln of a, 1 over u. Let's look at this problem. The derivative of x is y equals this. Okay, what we do is natural log, derivative of natural log is 1 over the u. This is my u here. So 1 over 3x squared times the derivative of the inside. I say u, say inside 2. Derivative of 3x squared is 6x. Now if we wrote this out, we got 6x over 3x squared. One of the x's will cancel off. 3 goes in there twice, so we're going to get 2 over x as my final answer. Now, if u is a differentiable function of x and u is greater than 0, log of base a of u is equal to 1 over u ln of a. And then the power rule. So let's block this off. I don't know why I didn't get these blocked off the first time, but let's look at these again. Let's copy this one down. Let's say this is my rule. Y is equal to this. So if we bring it out front, we're going to have the cube root of 4 times 5x to the cube root of 4 minus 1 times the derivative of the inside. The derivative of the inside is 5. So now if we look at the answer, what they had here, they had the 5 up front, the cube root of 3, and this minus 1. Same answer. It's just a different way of writing it. So we could write this as the 5 up front, so we get 5, the cube root of 4 times 5x to the cube root of 4 minus 1. So let's keep going here. Logarithmic differentiations. Sometimes the properties of logarithms can be used to simplify the differentiation process, even if logarithms themselves must be introduced as a step in the process. The process is called logarithmic differentiation. So we're going to do some more problems of the other ones in a little bit here. Let's say we have this. Now we can't do this and say, well, x is the base, subtract 1 because there is an x up here. So what we're going to do to start off with is we're going to do the natural log of both sides. Natural log of this side equals natural log of x cosine x. And simplify it down a little bit. Natural log of 1 is equal to the cosine of x, bringing it out front, times the natural log of x. Derivative of natural log is 1 over y dy dx equals, now this is the product rule here. The product rule, we're going to say u and v. So u cosine x times the derivative of v, 1 over x, plus natural log of x times the derivative of cosine, which is a negative sine of x. So we have 1 over y dy dx is equal to the cosine of x over x plus a negative sine of x times natural log of x. Now what we're going to do is we're going to take a whole thing there, times both sides by y to get dy by itself. That'll cancel off. So now we're going to get dy dx is equal to y. Y is x cosine x, x cosine x. And then we have cosine x over x plus negative sine of x natural log of x. Nasty derivative, but it does work out as we go. Now this last 2 pages are just some problems you can practice with as you go through derivatives, and I know some of the work is on here is derivatives. Now let's try a couple problems. In section 5, let's look at, I shouldn't say section 5, let's look at a couple of different problems here. Let's look at 13 first. Y equals 3 cosecant x. Y is equal to 3 cosecant x. Now my base is 3. So now if I was doing this one, well, we can think about the rules. We have a lot of rules back here with a number in the base. Well, I'm just going to page back real quick. Number in the base. Here's the one with the number in the base. A to the u, ln of a, and then derivative of that. Okay, so this one was going to be a to the u, so the dy dx is going to be equal to 3 cosecant x times natural log of 3 times the derivative of cosecant. Now, I don't remember the derivative of cosecant off the top of my head, so I'm going to look it up real quick. That's a derivative of trig function. And you guys, I know, have them all memorized by now. I can't imagine you don't. Derivative of cosecant is negative cosecant cotangent. So this is a negative cosecant x cotangent x. So that's a lot of different rules, but that's a long derivative. And then we have to set this equal to 0 to find my slope, when it's equal to 0 and so on down the line. But this gets us started on how to find the derivative. Let's try another one. Let's try log base 5 of square root of x. This is number 22. Y equals log base 5 of the square root of x. Now, if we remember the log rule, when we broke it down, is 1 over u. 1 over u natural log of a, u natural log of a, du over dx. So on here we're going to get 1 over the square root of x, so dy dx is equal to 1 over the square root of x natural log of 5 times the derivative of this. Now remember, x square root of x is written as x to the 1/2. So times 1/2 x to the negative 1/2. Now if we simplify that down, we're going to have 1 over the square root of x natural log of 5 times 1 over 2 square root of x. So we're going to have 1 over 2x natural log of 5 as we break it down. So in different ways of looking at the logarithms as we go through these. Which other one do we want to try? Let's try 25. I'm going to just try a few problems here. 25, we got natural log of 2 times log base 2 of x. Log base 2 of x. Now, a lot of people get confused on this one. Y equals, because you get that natural log of 2, but that's just a number. So if we're taking the derivative of this, we can just move that out front, not worry about that. Take the derivative of this. Well, the derivative of this first is 1 over x natural log of 2 times, now we're bringing this back in, because we get to the as of that, natural logs of 2 will cancel off, so the derivative of this function up here is just 1 over x, but x has to be greater than 0 because you can't plug in a negative number there going through it. Let's try another one. Let's try 30. At what point of the graph of y equals this is the tangent line perpendicular to this line? So we have y is equal to 3, what's it doing, number 30, 2e to the x minus 1, 2e to the x minus 1. So the slope of this one, dy dx, is equal to, derivative e to the x is e to the x, so 2e to the x. And it says, is the tangent line perpendicular to this? So, okay, perpendicular to this line. This line is a negative 3x plus 2. Negative 3x plus 2. Well, to be perpendicular to this line, the slope has to be 1/3. So we want to know when 2e to the x is equal to 1/3. So I'm going to put a cross multiply. I'm going to get 1 is equal to 6e to the x. Divide by 6. E to the x is equal to 1/6. Take the natural log of both sides. So x is equal to the natural log of 1/6. And this is at what point? So, okay, that's 1 point. So my x coordinate, what point is going to be? Natural log of 1/6, and now we're going to plug that in. Okay, so if we plug that into this equation, we're going to get y is equal to, we have to find the y coordinate, e natural log of 1/6 minus 1. Now natural log of those will cancel off, so we get 2 times 1/6 minus 1, 1/3 minus 1, which is a negative 2/3. So we're going to have a negative 2/3. At the point, then the slopes are going to be perpendicular to each other. There's a lot of problems I want you to do on here. One more. Let's do one more. I think we'll do one more here, and then we'll be done. Let's look at 52. It says the spread of a flu in a certain school is modeled by the equation this, where P of t is the total number of students affected for t days. Estimate the initial number of students affected with the flu. So if we estimated the initial number of students, this is at time 0, so we got 200 divided by 1 plus E5 minus t. So at time 0, we're going to have 100 plus e to the 5th. So I'm going to pull my calculator out. Hopefully it's still on. Okay, yep. So I'm going to get 200 divided by 1 plus, oops, I had to back up a second, divided by parentheses 1 plus e to the 5th. Enter. Oh, control enter, how about that? And it gives me about 1.33, so approximately 1 student. So for the question number 1 on this is number 52, part A, how many students are affected the initial? 1.33, which is approximately 1 student is affected. How fast is this flu spreading after 4 days? Now that's going to be the derivative. So part B, we have to take the derivative and plug it in. Well, let's go through here and say the quotient rule. There's a couple ways to do it. I'm going to use the quotient rule. The quotient rule says the bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom. Derivative of 1 is that. Derivative of e is going to be e to the 5 minus t times the derivative of the inside is a negative 1, makes it a positive, over 1 plus e to the 5 minus t squared. So my derivative, dy dx, is equal to 200 e to the 5 minus t over 1 plus e to the 5 minus t squared. So then it says, how fast is it spreading at 4 days? Well, so we're going to plug 4 in there. So 4 days, we're going to 200 e to the 5 minus 4 over 1 plus e to the 5 minus 4 is 1 squared. And this is 1 up here too. So if I remember the formula right, we're going to have 200 times e to the first divided by 1 plus e to the first. Oh, wait a minute. I have to back this up. E to the first divided by parentheses 1 plus e to the first. Control enter. 146. Well, I do something wrong here. Let me go back and look. How fast is it spreading? Oh, forgot a number. Let's go back here to the calculator again. I forgot to put that one on. Let's go back up here. Bring it down. And I have to go down here. And if you remember the formula, I forgot to put this into squared terms. Squared. Let's see what the answer is then. 39.32. Oh, that's pretty good. So approximately 39 students. So, okay. How fast is it spreading? About 39 students per day. Okay, when will the flu spread its maximum rate, and what is the maximum rate? Well, that one's a little hard. We have to take the derivative of this again. So instead of doing that, what I'm going to do is I'm going to go to my calculator. I'm going to enter a graph. I'm going to enter my derivative graph, which is 200 e to the power of 5 minus x divided by 1 plus, I think it was e to the 5 minus x. That whole thing squared. So I can see my graph going up. Now when it's spreading the fastest, I'm going to zoom out a little bit. Up here. I want to see it. Okay, that's where the spreading the fastest is, way up here. So I want to find the maximum point. So I'm going to go analyze graph, maximum, lower bound, upper bound. So when is it spreading the maximum? It's spreading the maximum. And here it says, okay, it's spreading the maximum at 5 days. 5 days. And the maximum students per day, 50 students per day as you go through. So 5 days at 50 students per day. So now hopefully that gets you through a few problems and gets you set up to do a few problems. So get you started. Thanks for listening.